So when I first arrived at the hacker house, I wasn't sure what I wanted to do. And then I was having lunch with Marcello and Bartolomeo and from Herodotus. And after discussing a lot of the possibilities, Herodotus today, its main tech stack is in Cairo. And I wanted to use Herodotus on Ethereum, on Ethereum smart contract, but there were some limitations because a Cairo proof is very, a Snark proof is very expensive to verify. So then we had the idea of, okay, why not verify the Cairo proof in SP1, make it succinct, literally, and then verify it on Ethereum. So that's how the idea came. And basically, the problem that we are solving here is that Cairo proofs or Snark proofs, they are very big, and they can be very expensive to verify on chain. Just for context, the Starknet OS proof can cost from $100 to $500 depending on the gas price, and it takes 5 million gas. So what we tried was basically the Herodotus team already had the Cairo verifier implemented in Rust. So my job was just plugging in. And the plugging in process was surprisingly smooth. And what we achieved is that we actually were able to decrease the cost of verifying Starknet itself by 3 to 40 times, comparing against the $100 cost, which is very low gas price. If the gas would be, let's say, on the average of a more active day, then it would be like 100 to 200 times cheaper. Plus, not oscillating so much as the gas price of Ethereum L1. And what this unlocks, maybe I can go with it for the demo first, and then I'll go. So this is a. So what I did actually, this was my first attempt actually building on SP1, and it worked out really smoothly. Everything I had to do to, I think this is an older version, but on the repo we have the up-to-date. All I had to do was to import the Cairo verifier, and literally with a few lines of codes, it was working. So this is all the code that we needed to add to be able to verify Cairo in SP1. Here we are importing a proof because we have a local proof, so we want to test. We just make some transformations, and then we call the verify, and that's it. And now you have a Cairo verifier in SP1. And I'm gonna run this. You already have the. So this is proving a Fibonacci program. So in Cairo, depending on the program that you prove, the proof size is gonna become bigger or smaller. So this is a simple one, and it takes 800 million cycles. And then we tried a few more things, which I'll be sharing right after. Is it big enough? Maybe I can make it bigger. So yeah, so literally like while we wait, I just like this is just importing the proof, like structuring the proof, and this line of code is the verification, and that's it. And it takes 800 million cycles to verify the Fibonacci program. What I think I'll go to some of the benchmarks before sharing. So what we did after, we said, okay, we just verified a Cairo program. Let's try more stuff. So there are many projects being built in Cairo. And one of the reasons why is because Cairo was very efficient. And there's a team called Succinct, which have proven the entire Bitcoin history in Cairo. So they have a Cairo proof of the entire Bitcoin history. So we thought, okay, why not verify the entire Bitcoin history in SP1? So similar to how Celestia, now you can sync with Celestia in a very fast way, you can now sync with Bitcoin with just a Snark proof. So any phone can like literally sync with Bitcoin with the proof. And it initially took us 32 billion cycles to implement it, to run it. But then Bartolomeo did some magic and added the Keccak precompile, and this reduced to 1.3 billion cycles, which is around $1.3 or $13 or less. And then the next idea we had, okay, we have verified Bitcoin, the whole Bitcoin history. Now anyone can have the Bitcoin Snark proof to be used anywhere. Why not try to verify a Snark OS proof, which is something that is already being used in production? Because like we have the Bitcoin proof, but we haven't seen many people use it yet. But Starknet proofs, like it is basically securing the entire Starknet L2. So if you can reduce the cost here, we're actually reducing the cost of something that is in production. And our hypothesis was, okay, if the zero-sync proof took 1.3 billion, if the Starknet proofs takes between 1 to 5 billion, then we can have a big cost, gain in cost. And we were able to verify it with 3.2 cycles. That's where the number of being 3 times to 40 times cheaper than the cheapest verification cost on Ethereum L1 today came. So, and this is, we just verified on Sepolia. I think you have it here. So the Snark proof is verified in Sepolia. And this is very exciting because it unlocks a lot of possibilities. Then I will go with the slide that I thought I would be talking about in a second. But so what does this unlocks? Now, any Cairo program can have access to a Snark proof. And this is a big deal because today, if you want to build in Cairo, although it's efficient and CircleStark is going to make it even more efficient, you have to rely on Starknet shard proofs to be verifying. But now, for example, with Kakarot, Kakarot claims that with the CircleStark, they will be able to prove an Ethereum block in less than 12 seconds. So technically, now we can also generate a Snark proof in less than 12 seconds. So ZeroSync just announced that they can prove in 90 seconds, but maybe with Kakarot and CircleStark's 12 seconds will be achievable. And we can prove Herodotus, we can prove Giza, which is the KML projects, and many others. So yeah, I think combining the improvements of a CircleStarks for doing some hard, like heavy computation plus SP1 on making the proofs succinct might become something that will allow us to build some interesting stuff. So this is our repo. Everything is open source. This was just an exploration project. So if you want to get it and use it and start verifying your Cairo proof, everything is there.
Great. Thank you so much, Lalo.